Hi, I'm Patrick.
I'm Landon.
I'm Chris.
I'm Nathan.
Hey, stop. I'm Patrick.
I'm Landon.
I'm Chris.
I'm Nathan.
Today, we're going to talk to you about the circuit project that we had to make a solenoid to shoot a little metal projectile. So, as we've already demonstrated to you before, our coil gun does work. We have got it to function properly, put in a lot of work on the actual circuit. Later on in the video, Chris is going to talk to you about that circuit. But what I'm going to talk to you about is basically kind of the project we were given and probably one of the harder aspects of it to complete. So that was being the actual solenoid. So a little of the physics behind the solenoid is when an electric current is sent through the solenoid, it actually induces a magnetic field. So one of the things we had to watch out for when we were doing the solenoid is we had to make sure that all the wraps were in the same way. If not, we would have had a magnetic field going one way and one coming the other way, and there would have been no force pushing that BB one way. It pretty much would have held it in the center. So with our coil, we'd started out building the coil out of about a 22 gauge coated copper wire. And we had gotten a coil built at the beginning, but we had failed to wrap it in the same way, so we were experiencing no electromagnetic force to send that BB out. So basically what we had was a coil that was useless. So we had first thought it was a circuit problem, so we were diagnosing that, and it just was not going too well. So what we did after that is we went to Lowe's Home Improvement Store, and we picked up some more wire and tried making another coil out of it and wrapping it all the same way once again, making sure to do that. And after that, weren't getting what results we were wanting, so John Higgins, an upperclassman that we're all friends with, he had some TV wire from an old TV, real thin copper wire, and we wrapped the coil with that, and we were able to get a lot of turns, and with those turns we were really getting the results we wanted. And also later on, Nathan's going to talk to you about the velocity that we were getting and some of the efficiency of this coil gun. So next, Landon's going to talk to you about the assembly of it.
I was in charge of making the kind of the housing unit for the circuit that we used, and the hardest part about this was finding a way of getting the button mounted in there where it would kind of stay in a stable position, so that way everything wasn't moving all over the place within the box. And the hardest part about that was whenever you drilled it and stripped out the wood, the threads at the base of the button weren't really up to par, so I had to strip about halfway through the board again with a 1-inch cutter, and basically after that I was able to get the knob to actually catch the threads. And then the reason I knew to drill a hole this way and mount the barrel in the way that it was because using the right hand rule you can tell really easily which direction the projectile is going to go. So if you go in the direction of the current with the way that we wrap the wire, you curl it in the direction of it, and where your thumb is pointing tells you where the projectile is going to go. So whenever I mounted that, I also drilled 2 holes on the opposite side that you can't really see, so that way there wasn't any potential for any current to jump from one wire to the other without passing through the solenoid. So now Chris will take over with describing the circuit.
Alright, so for this project we had to take the 3 disposable cameras we got and make it into obviously a coil gun. So what we did is we broke them down, took the individual circuit boards out of them, and we actually went through 3 in the process of making this experiment. But to begin, we took the capacitors off of each one and soldered them together. And I mean, this project was really good at teaching us how to solder, because I don't think any of us really had experience with it before. So we ended up soldering them together in parallel to increase our capacitance, obviously. And then we took one circuit board, our initial one, and we soldered them back on, connected it. Well, I guess we didn't connect it too good, and it ended up frying that circuit. So we get another one, and basically the same thing happened. Blah blah blah. So third time's a charm, I guess. And now we have it working pretty good. We got it connected from the gray side of the capacitors to the button, and then the button we have a like a little what gauge is this?
That's the 22 gauge wire once again.
So we have one of those types of wire. We have it connecting from the button to the front of the barrel. That way it can do as Landon and Patrick both described. It can induce that magnetic field going that way. And then we have the end of the barrel, the wires running all the way back to the other side of the capacitors. And the way we've been charging this is we tried to tie it down with like another piece of the wire, just or even a zip tie. We tried using that, but I think that's how it screwed up our second circuit. So other than that, it's about it for the circuit. I think Nathan's got you.
Okay, so to wrap up this video, we'll quickly talk about the efficiency. As you see here, we needed to, the 1/2s cancel out in the equations. So we need to define the mass, the velocity, the capacitance, and the voltage across the capacitors. To find the bottom two values, we need to find the capacitance and the voltage using the leads here. And you need to make sure you connect the leads to both ends of the capacitor. So we found that to be 295 volts and about 240 microfarads for all three together. The mass we found to be 0.1 grams and the velocity 14.5 meters per second. We plugged these values in and we made sure we had the grams and kilograms, and we ended up with joules over joules here. We found that value to be about 0.1%. So that's the efficiency of our launcher.
So that pretty much wraps it up. That was our coil gun. Some of the physics behind it, talking about some of the currents inducing a magnetic field. Talked about the circuit a little. So that's pretty much it. This is a great experiment to help us learn some pretty good ideas about how this physics works in real life. So hope you enjoy the video and have a great day.